In this video, we will talk about index lifecycle management with Elasticsearch version 8. In terms of what index lifecycle management is, I'll just read it from this definition here on the website. You can configure index lifecycle management policies to automatically manage indices according to your performance, resiliency, and retention requirements. For example, you could use ILM to spin up a new index when an index reaches a certain size or number of documents. You can create a new index each day, week, or month and archive previous one. You can delete stale indices to enforce data retention standards, and quite a few other things. In general, you can basically use ILM to automatically maintain the indices that are within your Elastic cluster. You can have indices automatically move from between various nodes given certain criteria. For example, you may have some nodes in your cluster that are optimized for read processes. Other nodes might be optimized for cold storage of old data. And depending on the nature of your index or your indices over time, you may wish to automatically migrate them to various nodes within your cluster. So that's what the ILM is. So I have an agenda here, and I was thinking about explaining everything in 4 parts. I may have to record this in 4 separate videos. I'm not sure. We'll see what happens as we go. So the first part I want to talk about is how you might manually manage these indices without the use of ILM. And when you manually manage these indices, we're going to come across some of these topics like allocation, index aliases, doing rollovers manually, and how to use custom attributes within the configuration files of each Elastic node. The second part, we'll talk about hot, warm, cold architecture, and we're going to migrate. And we're actually going to use ILM policies to do this. And we're going to use the allocation method. So we're going to talk a bit about index templates as well. Then we're going to repeat the same topic on hot, warm, cold architecture, but using the migrate process, which is a feature that, from what I understand, it came in Elasticsearch 7.10 and onwards. But prior to Elasticsearch 7.1, they were using the allocate method. So I thought it would be good to use both of them. And for both of these topics, we're going to do it with just regular indices. And then the fourth, and by the way, in here, we're going to talk a little bit about data roles as well as part of the migration process. And the final part of this tutorial will be using migration on data streams. So data streams are just another variation of indices, but I'll give a better definition once we get to this part in the video. So to start off, I've already set up an Elasticsearch cluster with 3 nodes, and the process I followed was basically this guide here. If you click on this, you'll just go to the public YouTube video I created on an Elastic cluster. You could use this one, or if you happen to be part of the YouTube membership that I've set up, there's also one where each node is using a privately signed, a private CA to sign each of the TLS certificates for each of the Elasticsearch nodes. And by the way, this membership area is kind of new. It's where I'm planning to post videos that are just kind of miscellaneous videos or topics I'm in the process of developing. If some of those videos reach a level of maturity that I feel is good for public consumption, then I'll make it a public video later on. But for the ones that are just kind of work in progress, I'll leave them in the private membership area. So this video here, you can follow this video to set up your cluster, or follow this video to set up a cluster. If you've set up your cluster in other ways, I think a lot of the subject matter in this video should still be relevant to you. Okay. So I've set up a 3-node cluster. I have 3 terminal windows open, just so you know, in case I need to reference them. So each one of these SSH windows just references each of the Elasticsearch nodes that I have. And each one of them, each node is actually using Ubuntu. So let me just, okay, so this version of Ubuntu. And I've already updated my host file because I'm hosting everything locally in my office network as a lab or demo. So you can see that each one of these nodes and the actual host file on my Windows computer, they have these 3 entries so that I can reference each node via fully qualified domain names instead of IP addresses, because IP addresses are hard to remember. All right, so that's my current setup. I've got these 3 nodes. I also do have Kibana set up, I believe. Yes, I have it here. So under Kibana, I already have the dev tools opened up, and you can verify that these nodes are here as well. I'm going to post most of my instructions into this Kibana console DevTools area here. But if you don't have Kibana installed, you could just do everything from command line, because as you know, the REST API for Elasticsearch is basically what this whole dev tool area is using anyway. So if I do something like this, the user I logged in with was Elastic, password is ABCD, 1, 2, 3, 4. I'm going to skip TLS root certificate CA verification thing because it's not that important for the purposes of this demonstration. So if I do a GET request to any of the nodes, 1, 2, or 3, 9200, and repeat this same API endpoint, so you can see it's the same content that comes up here. All right, so up to you if you want to follow this tutorial by using the REST API, or if you just want to paste it in here. I'll paste it in here into this Kibana DevTool area for now. So let's see if there's any other housekeeping items I should mention. Just give me a moment. Actually, so yeah, I think we can get started. So let's talk about this for first part. Let's manually create an index and go through some of the actions that you would need to do some maintenance on such an index. So let me go back to our DevTools here. And what I'll do is just hit enter to go to new line. First thing we'll do is let's actually create an index. Right, so I've got some code ready made. I'll just paste it in here, and I'll eventually share all this code that I use here in a markdown file in the GitHub repository. I'll just link to it in the description of this video. Okay. All right, so this first line here, it's pretty straightforward. I'm going to create an index, and I specified some optional field mappings. Well, let me just say that this index is demo there's 5 zeros and a 1. And the reason I chose hyphen 5 zeros and 1s because later on I'm going to create multiple versions of the demo to do something called rollover. And I'll talk about what rollover means later. Okay. So yeah, I just chose demo hyphen a bunch of zeros and 1. I defined some defined some field mappings here. You don't have to define it. I just want to keep things clean, so I might as well define it. The first field is a timestamp. It's going to be a date field. This field here is just the username, and I'll use keyword so that it doesn't get tokenized in any crazy way. And for message, it'll just be a blob of text, which I do want Elasticsearch to tokenize as part of their text analysis. So pretty straightforward. 3 fields in this index. In terms of just some settings about this index, I've asked Elasticsearch to don't make any replica shards and keep the number of shards to 1. And if you should know by now that within Elasticsearch, there are 2 types of shards. There's the primary shard where most of the work happens, and there's the replica shards that are great for fault tolerance and disaster recovery and backups and such. For the purpose of this demo, let's just keep it to 1 shard so I can get my point across. But all the concepts that we present, it could apply to multiple shards of any type, right? So by keeping it replica shards to 0 and the 1 primary shard only, it will, my cluster of 3 nodes, it'll have sufficient resources to perform our demonstration. So let's go ahead and create this index. Okay, pretty straightforward, right? Nothing crazy. Now let's take a little bit of a look at this index by running this command. I want to know where the shards are located for this index. So I'm just going to press run. And you can see that this index is found on this node here. Actually, yeah, so this index is found on this node. I was actually expecting some numbers here, so give me a moment. Let me actually insert a record into this index. All right, so I'm just going to insert a document like this, just username John Doe, a test message, and some random timestamp. Insert. Okay, it looks like it's inserted. Now let's run this command again. Okay, you know what? It should be fine. So, actually, let's make sure there actually are records in here. So I'm going to search this index. Great. So the record made it in here, and we see that this index, it's shard. Oh, here we go. Yeah, I was expecting the number of shards to appear here. So it just took a while to register. But now you can see that there's one shard of demo hyphen number, a lot of zeros and 1 on node 3. In my mind, when I was setting up this demo area, I had 3 nodes and I was thinking node 1 should be my, let's say, the hot node. Node 2 should be my warm node, and node 3 should be my cold node. And what I mean by that is for node 3, I was planning to put indices that are stale, not very, it doesn't really need high performance hardware because it's just really storage. So I can have these really old spinning hard drives or spinning disks that don't really perform that well, but it's great for storage. That's what I wanted node 3 for stale data. Node 2, kind of warm. Sometimes the data might be accessed, maybe not so much. And node 1, I want it to be the hot node, where that is the node that will get that will store the most recent data. There's going to be a lot of read and writes to it. So it has to be a very performant server. And this first index, given it's a brand new index, and I inserted one document into it, one of many that I plan to in a real world environment, because it's a new index, I want it to be on node 1. So I wanted it to be on a hot server. But right now it's on node 3, which I chose node 3 to be a cold server. So the first thing you might want to do is let's move this one shard of demo 1 over to our hot node 1. So how might you do that? And I have a command here that can help with that. So let me just get this over here. So let's go to down here, hit some new lines, and this command here is basically updating the settings of this index. So this settings endpoint is basically this field here. I am inserting this attribute into here, and that attribute is saying I want demo 0001 to be on node 3. Actually, let me correct that. I don't want it to be on node 3. I want it to be on a hot node. I want it to be on node 1. So if I do this, and then I go ahead and take a look at the shards of demo 1, you can see that it is now on node 1. So you might be asking, like, what is this index.routing.allocation.include._name? And let me pull up some documentation for that. Okay, so here's the documentation on index level shard allocation. And that's basically what we just performed. So in the settings here of our index, if we ever want to talk about allocation of shards, we can do that through the sub properties of allocation. Okay, index.routing.allocation. And what you can find is the documentation on all the different ways you can allocate your shard based on index.routing.allocation. And the one we used right now was name. We allocated a shard of an index based on the underscore name attribute, which you can see here. Okay. And you may want to know, what is this dot include then? Well, include is one of 3 verbs that you can choose to use. I use the word verb. Maybe Elasticsearch has another definition for what this is, but I call them verbs. And there are 3 verbs: include, require, and exclude. So if you use the verb include, then it means that if you have a comma separate set of values here, then Elasticsearch will try to find a node where one of the comma separated values is met. Now I know in our demonstration right here, an Elasticsearch node can really only have one name. But we're going to realize later on in fact, we're kind of jumping ahead to the next topic a little bit, which is or actually on the same topic, but we're kind of jumping ahead to attributes. Later on, we're going to learn something about attributes. They're kind of like tags or categories, and a node can belong to multiple attributes or categories or topics or tags. So when that happens, if a node satisfies one of those attributes, then Elasticsearch will try to assign demo1 to that node. But for the purposes of name, you can't really have many names. So whether you choose include or require being the other verb, I don't think it would matter here. So then the question is, what is the require verb? Well, the require verb is all of the attributes have to be met. So they're kind of like an and statement. So include is more of like an or statement, requires an and statement, and exclude is a NAND statement. Yeah, none of them may be satisfied. Okay, so those are 3 verbs. So that's how you interpret this statement here. Allocate demo1 to a node that has underscore name node1. And you can also, now we found out the node name here, right? But of course, you can actually confirm, and that node name is originally established in your Elasticsearch YAML file over here. Okay, so that's one way to allocate shards. So these are some of the more built-in attributes that Elasticsearch allows you to use. You can go by name, host IP, publish IP, etc., etc., etc. Okay, so if you find these attributes insufficient, you want to define your own attributes, like your own tags or categories, you can do that. So I can go into each of my Elasticsearch nodes. So let me open them all up here. Okay, so let's, for example, edit our Elasticsearch YAML file. And again, this is basically a clean installation straight from one of my videos over here. And what you can do is you can add your custom attributes here. So I already added this here, but commented out. I'll bring it back in. I'm going to add this attribute called my_identifier. You can define whatever attribute you want to call it. You can call it geography, you can call it server size, you can call it rack number, whatever you want. I'll just call it my_identifier, and I'll give it any value I want. I'll just put in the value beta. Right? I could type pizza, I can type sushi, I can type rock and roll, it doesn't matter. I'm just gonna call it beta, and then I'm gonna restart the server. Okay, so node 2 will have the attribute beta for my_identifier. And let's also do the same thing for this one. And what I can do here is, let's call this one my_identifier alpha. Okay, so let's do that on the 3rd node as well. And for this one, I'll call this third server Delta. All right, and then in a moment, I'll just wait until these finish up. Let's just see if, okay, node 1 is down, but let's take a look at node 2. Node 2 probably, or the cluster won't really be up until at least one other node is up because of that split brain effect that I've talked about in previous videos. Okay, so I'll just pause until all these nodes are up. Oh, actually, one of them might be up now. Let's go to node 2. There we go. So now our cluster is back up. And each one of these nodes should have a new attribute called my_identifier, each with a different value. You could, of course, reuse the value because maybe you have 3 nodes that want to share the same tag or same attribute. And then when you try to allocate the shards of an index based on tag, Elasticsearch will find any server that matches that tag. In this case right now, for our demo, each server, each node has a unique tag because I only have 3 nodes. So let's go back to Kibana now that the servers are up, and I can, let's say node 1 we know is alpha. Oh wait, let me just do this. All right, so demo is on node 1 is alpha, and now I can do a new command. Let's go down here. I'm going to allocate based on my_identifier, and let's change this to delta, and that should put it on node 3. And if I do look up on the shards, oh, let's see, maybe it didn't run yet. Okay, so let me take a moment to see why this might not have migrated. Okay, I think I figured out the reason. It's probably because these 2 settings, they're both in effect, they're both being respected, so Elasticsearch is saying that is probably thinking there's a conflict. Node 1 has alpha, but now you're telling me to put on delta, but delta's on node 3, so which rule takes precedence? My guess is, I don't know which rule takes precedence. I'm just going to guess that it's the last rule that was valid that would remain in place. So even though I try to execute this rule was in place last, so it's kind of in conflict. You guys can do some experimentation to see which rules take precedence, but I can fix it by first setting this to null, right? And now I'm just curious if Elasticsearch automatically knows to move it over to node 3. It doesn't, so let's actually do this now. Run the delta command, and there we go. Now it's actually going to node 3. So this older rule was still in effect, but by setting it to null and then running the allocation by attribute, that caused Elasticsearch to actually respect and honor this rule. Now let's actually try to move it to node 2. And if I click here, great, now it moves to node 2. Let's move it back to node 1. And there we go. So now we're able to move an index, the shards of an index, between nodes in our cluster using custom attributes. All right, so I think we've covered the basics of how to move the shards of an index around various nodes in your cluster. So how is this practical, or maybe it's now time to show you a practical use case for this. So let's talk about rolling over. Now, in a situation where this index, demo 1, over time could have a lot of documents, or it can get pretty old. And let's say if this index reaches 20 gigabytes, once it gets to 20 gigabytes, maybe you might want to move this index to a different server, to a different node, and start up a new index that will handle the newest reads and writes. Okay, so let's say we move this demo1 to a warm node. So I'm just going to move it to the warm node like this. And we're going to do what is called rolling over. Let's start a new index with exactly the same configuration, but call it demo-00002. Actually, let me give you a lot of space here so you're not always looking at the bottom of the screen. There we go. So let's start a new index called demo, a lot of zeros and 2. We're keeping with the same conventions as demo1 in terms of numbering. So we just increment to 2. Let's create this. And let's see where this is allocated to. Number 2. This is on node 1, which is great. I think Elasticsearch just arbitrarily picks which server, which node to put things on. And in this case, it put on node 1, which is our hot node. And that's great because all new inserts, I want to go to demo 2, and all the index on the warm node, I want it to be maybe only read only, okay, or at least not as performant. So let's try inserting records to demo 2. My second record. And let's actually just make sure it's in there. Great, so we've got records in the second index, and we've also got records in the first index. Okay, so we've got the new second index on a hot node, and we've got the older demo1 on a warm node. But the problem now is that if you want to search documents across both indices, you'd have to make one search, over here like this, and then you'd have to make a second search over here, right? I think you can use wildcards as well, but that can get you the records from both index. But you can already see it's kind of cumbersome to do things this way. So you probably want, or here's where the benefit of using aliases are. So you can set up an alias that points to both index when you're reading, and also points to one single index when writing. So let's create an index. I'm gonna paste this command here, just get some space. So let's create an index. So or let's create an alias. What this alias is saying is that I want to add for any new index that follows this pattern, demo-**. So this star reflects a wildcard for the zeros and ones and zeros and twos and such. Anytime we mention the word demo, it's going to reference any of these demo-** indices. Additionally, for the demo alias, for the purposes of inserting or writing, it's going to go to demo-02. Okay, so when we're writing to this alias, I want it to go not to number 1, only to number 2, because that is the most modern or newest index. So let's try this out. Okay, so it's created. And now when we do a search to demo like this, instead of using wildcards, you can use the alias to get documents back from both indices. And likewise, if I were to create a new record, so let's do an insert. I'm going to insert a new document to the index, and I can insert with the alias like this. You can see it was written to the second index, so that if I do a search, the third record isn't here, it's in the second index, and the first index It's still being read, but we didn't write anything to it. So that's how these aliases can be useful when you're creating these rollover indices. Let's actually make one more index, a third one, and update the aliases. So let's take this one again. Notice we're doing a lot of repeating, right? Every time I make a new index, I'm just repeating these same settings. So we're going to learn some tricks to not repeat ourselves so much. I'm going to create a third index, and now I'm going to update the index so that I don't want number 2 to be the right, I want number 3. So I'm going to copy this and repeat this, but this has already been made, so I don't need to make this. I'm going to make number 3 the right index. It is saying that, okay, so maybe I need to do a remove first. Let me remove this demo 2 and see if typing mistake of some kind. Okay, syntax error. Let's try this. Okay, fail to build alias action after last field required. Too many operations to declare. Okay, well, let me just try removing this one first. Oh. Okay, and now let's do the add again. Now let's see if it will let us do number 3. Okay, that took a bit of time, so I'm curious if something went wrong. So I'm just gonna do a quick search of the aliases here. Now there's a lot of built-in aliases in Elastic and Kibana. We're gonna look for the ones that are specific to our demo. So we have the demo alias will link to number 1. It'll also link to number 3, also links to number 2, but we can see it's number 3 that is the right index, which means if I were to insert another document, this should go to the 3rd index. And let's do a search on the alias. 1 index, 2 index, 4th. It looks like we're missing something. Let's see. I wonder, where's the search? Okay, we can verify that number 2 didn't get destroyed. All right, so number 2 is still here. I'm just curious why this alias doesn't map to all of them. Let's check our aliases here again. So aliases, this is incorrect. I am missing a demo in this one. So let's actually add it back. Aliases, add demo number 2. It's not a right index. Let's do this. And now let's do our search again. Demo, great. We've got our first record. Our second record is in the second index. Third record was in the second index. And our 4th record is in the 3rd index. So this is looking okay to me. 5th should belong in the index number 3 as well. Or node 3. Or I mean, node 1, but, whoops. I just did this. I don't think that would have caused anything, but let's take a look. Great. So our 5th record is now in demo 0003. So what we've seen now is that we can use an alias to help with our rollovers. Every time we create a new index with a new suffix that just increments by 1, this alias can always map to it. And what we've done is Let me just look at my agenda notes here. We've basically learned how to manually manage our own index life cycles through allocation, using rollovers and attributes and aliases to read from the appropriate indices and write to the appropriate indices. And you can see that was pretty laborious, manually going through all that. This is where index lifecycle management policies can basically automate all this. So I'm going to talk about the second topic in the next video because this video is already pretty long. But what I'm going to do is let's do some cleanup and let me tear down these demo resources that I've set up. Let me start with delete. And it was demo. So let's delete all these. Okay, I delete all 3 indices. Let's do a quick check to see if they are deleted. Okay, it looks like none of the ones that we created are in here now. And let's also remove the aliases. If I do this again, oops. Remove this alias. Oh, index not found. Oh, it might be that the moment I deleted these indices, the alias also gets removed. Let's do a quick check with a get alias. Right, looks like the aliases are removed as well, so that's good. All right, so now we can just move on to the next topic in the next video.